Hi, welcome to this session. Today we are going to discuss some of the problems, some of the recurrence relations which are non-homogeneous, and we are going to solve those recurrence relations now. Now, in the previous session, we considered 4 different cases to assume what is the particular solution for the non-homogeneous recurrence relation. So, in that, the first case one is if f of n is a polynomial of degree n, then 1 is not root of the auxiliary equation. Then the assumed particular integral as an power p, which is equals to then a0 plus a1 n plus and so on plus an power into n power q. If it is a polynomial of degree q, if it is a polynomial, f of n is a polynomial of degree q and 1 is not root of the auxiliary equation. Suppose if it is a degree of 1, then up to here we have to consider. If it is a degree of 2, then we have to consider a0, a1 n plus a1, a2 n square, like this we have to consider. It is true whenever 1 is not root of the auxiliary equation. Now, if I am going to solve this, so here what is the auxiliary equation is k square plus 4k and plus 4 is equals to 0. Then this will become k plus 2 whole square equals to 0. So k equals to minus 2 comma minus 2. Then this is the homogeneous solution is an power h is then a plus bn and minus 2 to the power of n. It is a repeated root. Now here 2 is a root, minus 2 is a root of the auxiliary equation, and now f of n is a constant here. F of n is 8, so which is a constant. So the assumed particular integral, we are going to take it as a constant. If it is a polynomial of degree 1, up to here we have to consider. If it is a polynomial, this is we are considering it as a polynomial of degree 0, so we are going to consider up to here. So now this is a n power p is equals to a naught. So this is the assumed particular solution of the given recurrence relation. Now what is now we have to calculate what is a naught. So this is the assumed particular solution, then it satisfies the given recurrence relation. So an power p plus 4 an minus 1 into p plus 4 an minus 2 to the power of p is equals to 8. So this is a naught plus 4 a naught plus 4 a naught is equals to 8. So which is equals to 9 a naught is equals to 8. So a naught is equals to 8 by 9. So whenever if it is 8 by 9, then an power p is equals to, we are getting only 8 by 9. Then the complete solution is equals to an is equals to an h and next to an p. So this is the complete solution to the given recurrence relation. So which is equals to, then this will become a plus bn and it is minus 2 is a repeated root, minus 2n to the power of n, and then another one is plus 8 by 9. So this is the general solution. This is the general solution to the given recurrence relation. Now we have to apply the particular cases. What are the cases are given? A0 is equals to 1 and A1 is equals to 2. So I am just taking, if n is equals to 0, then A0 is equals to, just substitute, this is A and this will be 1 plus 8 by 9. So A0 is, let us say I am just taking it as A0 is equals to 1 is there, minus 8 by 9 is equals to A. So I'm going to get A is equals to 1 by 9. Next, n is equals to 1 if I substituted, then it is A1 is equals to A plus B, and next it is minus 2 plus 8 by 9. So which implies A1 is, what is A1 is 2, A1 is 2, 2 minus 8 by 9, this 8 by 9 I took the side, so it is minus 2 into A plus B. Then it is minus 2 into A plus B, which is equals to 18 minus 8, it is 10 by 9. 18 minus 8 is 10. So it is 2 5s. So A plus B is minus 5 by 9. And of course A is equals to 1 by 9. Just 1 by 9 plus B is equals to minus 5 by 9. So B equals to minus 5 by 9 minus 1 by 9. So it is minus 6 by 9. So it is minus 2 by 3. Then this solution is just after finding A and B values, just you substitute into that expression. So AN is equals to A is equals to 1 by 9 plus BN. B is equals to minus 2 by 3. So it is a minus 2 by 3 N, and next minus 2 to the power of N plus 8 by 9. So this is the final solution. That means that this is the particular solution for the given recurrence relation. Now let us go for the other example. Just I am going to take this. So here you observe this is a constant. This is a constant, and 1 is not root of the auxiliary equation. 1 is not root of the auxiliary equation. Now you are going to consider another problem. And here what is the auxiliary equation is? The auxiliary equation is k square minus 4k and plus 3 equals to 0. Which implies the roots is nothing but k minus 3 into k minus 1, which is 0. So subsequently k is equals to 3 comma 1. K is equals to 3 comma 1. So I am going to get the roots are 3 and 1. Then the solution is an power h is, then this is a and 3 power m plus b 1 to the power of m. So this is the solution for the homogeneous. Now here 1 is the root of the auxiliary equation. Then the assumed particular integral, as earlier if it is not 1 is not root of the auxiliary equation, this is. If 1 is root of the auxiliary equation with multiplicity m, then it is whole thing is multiplied with n to the power of m. The whole thing is multiplied with n to the power of m, the whole expression we have to write. And here it is a simple root, so m is equals to 1, then I have to take n into, so it is a n into a naught. So now this I am going to take it as a naught into n. Now once again after finding this, just we are going to, this is the assumed particular integral, so it will be satisfies the given equation. So an plus 2 whole to the power of p minus 4an plus 1 whole to the power of p plus 3an whole to the power of p is equals to minus 200. Because it is assumed that it is a solution for that, so it satisfies the given equation. So now an plus 2 is nothing but a naught into an power p is this. So a naught into n plus 2 minus 4 into n plus 1 is a naught into, then just I am taking it as a n plus 1, then plus 3 a naught into n is equals to minus 200. Now this is a naught and it is a n plus 2, then minus 4a naught into, then this has n plus 1, then 3a naught into n is equals to minus 200. So just to take a naught as common, then n plus 2, then minus 4n minus 4, and the next plus 3m is equals to minus 200. So now this is what we are going to get, n plus n, it is 4n. This will be simplified. Then it is minus 2a naught is equals to minus 200. So which implies a naught is equals to 100. So this is a naught. While we are going to find out the a naught in this way. So after finding this, then what is the assumed particular integral? A naught power p is equals to a naught. A naught, capital A naught is 100 into n. This is the particular solution. Then the complete solution for the given recurrence relation, let us call this as 1. Then I am going to write it as an power, an is equals to an power h plus an power p. So this is equals to a into 3 to the power of n plus b into 1 to the power of n plus 100 n. So this is just the solution, general solution of the given recurrence relation. Whenever if it is a general solution of the given recurrence relation, then we are going to find what are the particular values. That means what is a and what is b by considering this. So here it is given that n is equals to 0. So if n is equals to 0, then this will become, so it is a0 is equals to, then this is a, and now this is a plus b, that's all, a plus b. So a naught is a plus b is equals to, a naught will be 3000. So this is 3000. Call this as second equation. Then I'm just taking all this as a second equation, while I'm going to consider this as a third one. Then n is equals to 1 if I'm substituting, then a1 is equals to, then it will become 3a plus b, 3a plus b, 3a plus b plus, and n is equals to 1. So subsequently it is plus 100, plus 100. So this is equals to, a1 is given as 3300, minus 100 is equals to 3a plus b. So this is 3200 is equals to 3a plus b. Call this as 4. And if I am solving equation 3 and 4, then we came to know what is a and what is b. So we are going to get a is equals to 2900, b is equals to 100. Just simply add, then we are going to get, this is just by simple linear, simple equations are there. Just we are going to simplify that. We are going to get the final as a and b as this. After getting a and b, then an is equals to the particular solution we are going to substitute. A is equals to 2900, and next it is b to the power of 3 to the power of n, then plus b is 100, and next 100 into 1 to the power of n, 100 into 1 to the power of n, and plus, then the remaining is 100 n. So this is the final solution for the given recurrence relation. Now let us go for the other one. So here this is while we are going to consider non-homogeneous equation of this, then absolutely the auxiliary equation is just we have to take k square plus 2k minus 3 equals to 0. So then this will become k square plus 3k minus k and minus 3 equals to 0. So from this we are going to write k into k plus 3 minus 1 into k plus 3 equals to 0. So I am going to get k minus 1 into k plus 3. So subsequently we are going to get k equals to 1, k equals to minus 3. Now 1 is the root, right? You observe 1 is the root. Now an power h is whatever the given is. Let us say this is equation 1. Now an power h is a into 1 power n plus b into minus 3 power n. Okay, this is let us say this is 2. Now we are just finding the assumed particular integral. What is an power p is? An power p is equals to, then this is a polynomial of degree 2, and if the polynomial of degree 2 is a0 plus a1n plus a2n square. If it is a polynomial of degree 2, we are going to assume in this way. And provided 1 is the root, if 1 is not root of the auxiliary equation, then this is right. If 1 is a root of a simple root, so we are going to multiply with n. If it is repeated twice, then I am going to take it as n square. If it is repeated thrice, I am going to take it as n cube, like that. So here it is a simple root, so I am going to take it as like this. So an power p is this, so which is nothing but a0 n plus a1 n square plus a2 n cube. So now it is the assumed particular. Then we are going to find out what is a0, what is a1, and what is a2. So while we are going to substitute in that expression. So if I am going to say that it is the solution, it is the solution for equation 1. So it will be satisfies that equation. An power p 2an minus 1 whole power p minus 3an minus 2 whole power p is equals to 4n square minus 5. So here we are going to substitute an power p is a0 n plus a1 n square plus a2 n cube. This is for this. Plus 2 into and for this. So I am just to substitute a0 n in the place of n minus 1 plus a1 n minus 1 whole square plus a2 n minus 1 whole cube minus 3 into, then the remaining we are going to substitute here as minus 3 into an minus 2 is nothing but a0 n minus 2 plus a1 n minus 2 whole square plus a2 n minus 2 whole cube is equals to 4n square minus 5. So in this expression, if you are going to simplify and take the constant terms, and next another one is n terms, and next n square terms, and next n cubed terms, n square terms, n cubed terms, and we are going to rewrite this as like this. We are going to write this is a constant terms, this is a quotient of n terms, this is quotient of n square terms, this is a quotient of n cube terms, which is equals to right hand side is 4n square minus 5. Now here just we are going to compare. We are going to compare constant terms, n terms on both sides, n square terms on both sides, n cube terms on both sides. Then we are going to get 1, 2, 3, 4 equations. 1, 2, 3, 4 equations. After getting these 4 equations, we are going to solve these 4 equations. Then we came to know what is a0, what is a1, what is a2, and these values we are going to calculate, and we are going to substitute these values into that expression. So this is the way that we are going to calculate. See here, just after getting this, after simplifying, just try to do that. So I am going to simplify that. And finally, we are going to get a0 is equals to 1 by 4, a1 is equals to 5 by 6, and a2 is equals to then 1 by 3. So just whatever here we are going to get, this is a constant terms. That means what are the constant terms is minus 2a0. and next here it is it will become A naught, A1, then it is A2, like that those terms will come here, and then A naught, A1, something we are going to get into n, and something we are going to get in square, something we are going to get in cubed is equals to them. Then we are going to write this as 0n cubed, next 4n square, then 0n, and next minus 5. So n cube terms, if you are going to compare, this is equal to this 0. Then n square terms, this is equal to 4. And n terms this is equals to 0. Constant terms is minus 5. So you are getting different 4 equations. If you are going to solve the 4 equations simultaneously, we are going to get A naught, A1, A2 values. After getting A naught, A1, A2 values, then A power P is, this is nothing but, just we have to consider it as A naught. A naught is just we are going to substitute all these values into this expression. So A naught into this is the expression. Then n into, just we are taking n into A naught 1 by 4, and next A1 5 by 6 n plus A2 1 by 3 n square, 1 by 3 n square. So this is the assumed, this is the particular solution. Then the complete solution is n is equals to an power h and an power p. Then I'm just considering this. Equation 3. Then just substitute equation 2 and equation 3 here. We are getting the final result. Now let us go for the other example. So here this is non-homogeneous. Here it is 3 power n is there. So here the case 3, it comes under case 3. What is the case 3 is alpha f of n, which is of the form alpha b to the power of n. Alpha b to the power of n. If it is the alpha is some constant, b is not root of the auxiliary equation. In such a case, the assumed particular integral as just A naught, and whatever the value here, the same thing we are going to consider. A naught b power n. So here b is not root of the auxiliary equation. We have to consider this. Okay, it comes under third one. Third case. If it is b3 is the root of the auxiliary equation, then we have to multiply. If it is a simple root, we are going to multiply with n. If it is a repeated root, we are going to multiply with n square. So now let us say repeated root means it is 2 times repeated. Then so here we are just solving this one, and we are just the auxiliary equation is k square plus 3k and then plus 2 is equals to 0. So what I am going to get, k equals to minus 2 minus 1. So I am going to get an h homogeneous solution is a and minus 2 to the power of n plus b minus 1 to the power of n. This is one solution. Let us call the given equation as 1 and this as 2. Now we have to assume what is the particular solution. Now this is just we are going to take it as here 1 is not root, so I am just taking 3 power n and same thing, and I am going to take it as a naught. I am going to consider it as a naught. So the assumed particular integral as a naught into 3 power n. Now here, what is the value of a naught that we have to calculate. So if I am going to substitute in the equation 1, if it is a solution, then this will become an plus 2 whole power p and 3an plus 1 whole to the power of p plus 2an whole to the power of p is equals to 3 power n. Then if I am substituting, then a naught, an plus 2, this is the 3 power n plus 2, then 3, Then this is what I am taking. The second one is the 3 into and a naught 3 power n plus 1 plus 2 into a naught and 3 power n, which is equals to 3 power n. Now here just we are going to take it as a naught. So I am just taking 3 power n as common. Just in this, I am just taking 3 power n as common. Then 9a naught from this. And from this, once again, 9a naught I am getting 3 power 1 into 3. And the next 2a naught is equals to 3 power n. Then 3 power n, 3 power 18, it is 20a naught is equals to 1. So a naught is equals to 1 by 20. Now, what is the assumed particular integral as a n power p is equals to a naught is 1 by 20 into 3 power n. 1 by 20 into 3 power n. Call this as 2. Now, this complete solution is a n is equals to a n power h and a n power p. So a n power h is equals to just a, and next it is minus 2 power m plus b minus 1 power n, and next this is equals to what is a 1 by 3 power n by 20. So it is a 3 power n by 20. This is a n. This is the general solution. This is the general solution. Once again, the same way like the previous problem, substitute n is equals to 0, n is equals to 1, n is equals to 0. Then I am going to get a naught. What is a naught is a plus b, and 3 power 0 is 1 by 20. Then a naught is what is 1. So a plus b is equals to 0 minus 1 by 20. So it is a minus 1 by 20. So it is a naught is equals to 0. Then similarly, if I just substituted n is equals to 1, what I am going to get? A1 is equals to minus 2a minus b plus 3 by 20. So it is 1 is equals to minus 2a, and next to minus b is equals to 1 minus 3 by 20. So these are the two equations I am getting. If we are going to solve these two equations, finally we are going to get a is 20 by 8. See, 5 2 is 4 5 is 4 2 is it is a is equals to 5 by 2, and the corresponding b values also we are going to get from this expression. From this is not a is equals to, from this what we are going to get, n is equals to so this I am just going to calculate. Let us say a plus b is equals to minus 1 by 20. Then what is a minus 2a plus minus b is equals to 20 minus 3 by 20. So it is 17 by 20. So it is a 2a. Just this is another equation. Just I am going to consider 2a minus b is equals to 17 by 20. I am not going to consider this. So this expression is minus 2a minus b is equals to 17 by 20. So just adding these two, then I am going to get a minus a is equals to, just adding 7 by 17, it is 16 by 20. So a is equals to 4 4s and 4 5s. So it is a minus 4 by 5. So simultaneously b is equals to, what I am going to get, b is equals to, a plus b is equals to 1 by 20. So minus 4 by 5 minus 4 by 5, and next plus b is equals to minus 1 by 20. So then from this I can calculate the b value. After substituting b value, a and b values, you substitute in this expression, then we are going to get the final answer for that. In this way we are going to do. Now let us go for the other example. Solve the recurrence relation of this. So here once again the auxiliary equation is k square plus 4k plus 4 is equals to 0. So I am going to get k plus 2 is equals to whole square equals to 0. So k is equals to minus 2 comma minus 2. So minus 2 is repeated. 1 is not root of the auxiliary equation. So then we are going to take it as minus 2. Minus 2 here, not more 1. See? Minus 2 is a repeated root here. So what is the solution for the homogeneous is a plus bn and next minus 2 to the power of n. Call this as given equation is 1 and this is 2. Now just here minus 2 is the root. Minus 2 is a repeated root, not a single root. So now an power p is so then it is I am going to take, if it is 2 minus 2 is not root auxiliary equation, then this can be written as a naught and minus 2 to the power of n. If it is minus 2 is not a repeated root. If it is a repeated root, then I am going to write how many times it is repeated? 2 times. So I am going to write into n square. If it is a simple root, into n I am going to write. If it is repeated twice, into n square. So I am going to write it as n square minus 2 to the power of n. Once again, we have to substitute in that expression. Then let us say an power p, then 4an minus 1 power p, and next 4an minus 2 to the power p is equals to 5 into minus 2 to the power of n. Then in this expression, substitute and finally calculate a naught. So it is nothing but just a naught into n square into minus 2 power n, and next 4 an minus 1. It is nothing but a naught into n minus 1 whole square and minus 2 to the power of n minus 1, and next plus 4 into a naught and n minus 2 whole square and minus 2 to the power of n minus 2, which is equals to 5 into minus 2 to the power of n. So now once again you just expand this. And you are going to expand this and simplify minus 2 to the power of n terms on both sides. Then you are going to get a naught. So generally a naught after simplification of this, a naught is equals to then 5 by 2. After getting the value, then you have to substitute in the assumed particular integral as this is a n power p is equals to then 5 by 2 n square and then minus 2 to the power of n. Then the complete solution, that is a n is equals to a n power h. Let us call this as 3. Then a n power h, and next another one is a n power p. So this is nothing but equation 2 plus equation 3. Then we are going to get the final solution for this. So with this, we are going to conclude this. This is some of the problems which comes under non-homogeneous recurrence relation. That is f of n, which are the 4 different types. Then how we are going to assume a particular integral, and after that how we are going to find the coefficients in that particular integral. So that we are going to know this. The things we are going to understand from this. With this I conclude the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.